Albert Einstein once set out to imagine a universe that was eternal, a quest that ultimately led him to clash with his own groundbreaking theory. This audio course follows the evolution of his thoughts on the cosmos's origins, from his renowned cosmological constant to his profound reaction to the realization that the universe was not static, but was in fact expanding. You are invited on a journey into the intellect of a man who fundamentally altered the course of physics and delved into the very instant of creation. Einstein was far more than a physicist. He was a thinker who operated beyond the confines of his era, unlocking new paradigms for comprehending the universe. Have you ever considered what compels a brilliant intellect to probe the most profound enigmas of existence? From his earliest years, he possessed an unquenchable curiosity, and this drive to grasp the mechanics of the world around him spurred the creation of theories that captivate us to this day. The enduring power of Einstein's work stems from his remarkable gift for translating immensely complex concepts into understandable ideas. His method involved using simple analogies and relatable examples to make the abstractions of physics accessible to a wider public. For instance, his theory of relativity invites you to envision time itself as a malleable material, a fabric that can be bent and distorted, much like a canvas stretched under immense weight. It might surprise you to learn that, prior to Einstein, the accepted scientific model of the universe was profoundly different, with most believing the cosmos was fixed and unchanging. However, his discoveries directly contradicted this long-held belief, opening the door for new theories about how the universe dynamically moves and evolves. His impact on modern cosmology is simply undeniable, as many principles we now accept as fundamental owe their origins to his audacious vision. Einstein also imparted the lesson that curiosity is a force that should never be restrained. In an age where science can often seem like a daunting collection of obscure formulas, he demonstrated that investigating the universe is a thrilling adventure filled with fascinating questions. What if the cosmos has no end? What exists beyond the limits of our vision? These inquiries compel you to look deeper into space and time, prompting the essential question of where we fit within this immense cosmic puzzle. When you examine his life, it is remarkable to consider how such an extraordinary mind could formulate concepts that once seemed to belong in the realm of fantasy. Einstein's existence was a dual journey of personal and professional exploration, with each step guiding him closer to the truths he relentlessly pursued. His profound passion for the cosmos and theoretical physics served as the engine for all his work, leaving a legacy that continues to fuel the ambitions of scientists and visionaries today. I want you to think about this. What kind of change would occur in your own life if you started to question everything you see? Einstein didn't just passively wonder about his environment. He actively challenged the established truths of his time. His life story serves as a powerful reminder that the most revolutionary answers can often emerge from the most elementary questions. His work's significance radiates far beyond the field of physics, as the ways we now perceive time and space have deeply influenced disciplines ranging from philosophy to cosmology. You might wonder how a single individual could so radically reshape our collective view of reality. The key was his capacity to see the world from a completely different viewpoint, a skill that I believe any of us can cultivate. And what of his legacy beyond science? Einstein's influence isn't merely contained within his discoveries. It is vividly alive in popular culture, where his very image has become an emblem of genius. Across films and literature, his name summons feelings not only of knowledge, but also of deep curiosity and boundless imagination, prompting the question of how a scientist managed to become such a cultural icon. Contemplating Einstein's life and contributions, leads us to a pivotal question. How can you integrate his method of inquiry into your own experiences? The quest for understanding is a lifelong voyage, and every one of us has the capacity to explore the universe's mysteries, even from our unique vantage point. His true legacy is not simply a collection of physical laws, but an enduring invitation to embrace curiosity and pursue knowledge, reminding us that there is always something more to find. When you picture Albert Einstein, it is natural to conjure his classic image, the untamed hair, the intense gaze, and a boundless curiosity that drove him to unravel some of the cosmos's greatest secrets. But what was the force that compelled this genius to devote his life to physics, and specifically to charting the mysteries of the universe? Einstein's journey did not start with intricate equations or world-changing theories. It began in his childhood home, where inquiry was as vital as breathing. From his very first years, Einstein displayed an uncommon fascination with the universe. A well-known story tells of him receiving a compass from his father at age 5, a simple device that ignited a lifelong obsession. He was captivated by the question of why the needle consistently pointed north, regardless of how he turned it. This initial puzzle set him on a path of contemplating the unseen forces that govern our world, a characteristic that would come to define his entire career. As he matured, his intellectual interests drifted toward subjects that many of his peers considered excessively abstract, and his teachers in school often struggled to grasp his unique thought processes. Rather than adhering to prescribed methods, Einstein chose to venture into new intellectual territory, driven by the belief that there was too much left to discover to simply accept established facts. It was this very mindset that guided him toward mathematics and physics, the two pillars upon which his later achievements were built. Einstein's path was strewn with difficulties, and he frequently felt like an outsider among his contemporaries. Yet he transformed every obstacle into a chance to learn more about how the world works. How could a young man who felt so disconnected from society rise to become one of history's most transformative scientists? The solution is found in his persistence and a powerful, unyielding desire to comprehend the universe, which ultimately motivated him to leave his native Germany and pursue new possibilities in Switzerland. During his time at university, Einstein developed a profound interest in the electromagnetic theory of James Clerk Maxwell and the principles of relativity, first explored by Galileo. These powerful ideas fired his imagination, causing him to question whether space and time were truly as absolute and unchangeable as everyone had long assumed. This burgeoning skepticism, fueled by his deep curiosity, effectively planted the seeds that would grow into his future revolutionary theories. How can a mind filled with questions transform those inquiries into something real? Following his university education, Einstein took a position at the Bern Patent Office. While it might have appeared to be a conventional job, this role provided him the space to contemplate and cultivate his theories. In his spare moments, he delved into concepts that would ultimately reshape our entire perception of the universe. The question naturally follows: how did a job that seems so ordinary serve as the launching pad for a complete overhaul of physics? During this time, Einstein started composing papers that fundamentally contested the established principles of physics. His first significant publication on special relativity marked a genuine watershed moment, in which he contended that space and time were far more pliable than anyone had previously imagined. But what makes this insight so critical? By challenging these foundational concepts, Einstein unlocked a completely new framework for comprehending the cosmos, almost as if he had discovered a new lens for viewing reality itself. His intellectual curiosity wasn't confined to physics alone. He was equally captivated by philosophy and the natural world, both of which were vital sources for his creative genius. What is the function of curiosity in making new discoveries? For Einstein, it was the very thing that sustained his intellectual passion. Through his work, he not only addressed scientific puzzles, but also explored deep philosophical questions, prompting him to consider humanity's position within the immense expanse of the universe. Einstein's personal life also had a significant bearing on his scientific pursuits, as his marriage and other relationships frequently became entangled with his cosmic reflections. It seemed that every personal obstacle he faced echoed the very complexity of the universe that captivated him so much. This leads one to ask how our own life experiences mold our comprehension of the world around us. For Einstein, every event, positive or negative, fueled his relentless pursuit of knowledge. In many respects, Einstein's entire existence was an expedition of discovery. As he ventured further into the domain of theoretical physics, his fascination with cosmology intensified. By the time his life drew to a close, he was revered not merely as a brilliant physicist, but as a philosopher who redefined our place in the cosmos. How could a single individual exert such a transformative influence on our perception of everything? Throughout his life, Einstein demonstrated that curiosity is indispensable. He taught us that the very first step toward discovery is to question what we accept as fact. In a world that often insists on definite answers, his legacy encourages us to never stop investigating and posing questions. Isn't this the very heart of science, an unending quest for understanding in a universe that consistently reveals new mysteries? Albert Einstein's life story stands as a powerful testament to the idea that curiosity and passion are the engines of human advancement. His narrative isn't just about a singular genius, but about a relentless explorer who motivates us to gaze at the heavens and ponder what more lies beyond. In the end, the most crucial lesson Einstein offers might be that the universe is a perpetually unfolding enigma, and our job is to keep exploring, dreaming, and, above all, learning. The theory of relativity, a concept that completely altered how we understand space and time, remains one of Albert Einstein's most profound contributions. But what is the true meaning of relativity, and what makes it so pivotal? To grasp this, you must immerse yourself in the remarkable ideas that Einstein bequeathed to us. Let's begin by considering speed. When you travel in a car, you perceive the world moving around you, and if you accelerate, your surroundings become a blur. But what if you could journey at the speed of light? Einstein shows us that time operates in a very peculiar way under such conditions. The faster you travel, the more slowly time progresses for you in relation to someone who is not moving. While this might seem like a plot from a science fiction story, it represents one of the foundational principles of special relativity. Introduced by Einstein in 1905, this theory rests on two core postulates. First, the laws of physics are identical for every observer, irrespective of their velocity. Second, the speed of light remains constant for all observers, no matter how they are moving, a notion that defies our ordinary perception. How is it possible for something as basic as light to hold a steady speed under any circumstance? This is where Einstein starts to reveal a new universe of possibilities. Picture yourself as an astronaut, moving at nearly the speed of light. Peering out of your spacecraft, you would observe stars appearing stretched, and time on board ticking by much more slowly. This effect is known as time dilation. Were you to return to Earth after an extended voyage, you would discover that your friends and family had aged considerably more than you had. This idea is not just a fascinating thought experiment. It has been confirmed through tests involving atomic clocks operating at high velocities. General relativity, which Einstein presented in 1915, expands upon his earlier concepts even further. Within this framework, he puts forth the idea that gravity isn't merely a force acting over a distance, but is instead a curvature in the very fabric of spacetime. Envision space as a vast, flexible sheet. If you set a massive object, like a planet, on this sheet, it creates a depression. This dip illustrates how large objects warp the space that surrounds them. In this model, planets and stars don't just drift in space, they travel along the curved trajectories of spacetime itself. Why is this so significant? It completely transforms our view of the universe. Rather than seeing gravity as a force that draws objects together, we now comprehend it as the path that objects naturally take through a warped landscape. This perspective enabled scientists to predict phenomena such as black holes, areas in space where the gravitational pull is so intense that nothing, not even light, can break free. Relativity also explores the idea that time and space are fundamentally connected, not as distinct phenomena, but as components of a larger, unified whole. A connection that has had deep repercussions for our understanding of the cosmos. This raises some captivating questions. What if someone could journey back in time and alter a pivotal historical moment? What would such an act mean for the very fabric of time? While Einstein didn't explore time travel in the way films do, he gave us the revolutionary concept that time is not the straight line we perceive. Instead, it is a complex dimension that can be warped and stretched in ways we are only just beginning to grasp. The theory of relativity has become a cornerstone of modern technology, with a prime example being the Global Positioning System, or GPS, which must correct for time dilation to give you an accurate location. Without Einstein's insights into relativity, GPS simply would not work, and your daily life would look profoundly different. It is truly incredible how a collection of abstract equations and ideas has evolved into indispensable tools we use every day. Einstein revealed that science is not merely a collection of established facts, but rather a method for investigating the universe and our own place within it. The conclusion drawn from his theory of relativity gives us an entirely new framework for understanding space and time. It compels you to move beyond your everyday intuition and recognize that the cosmos is a far more bizarre and magnificent place than you could ever have dreamed. As you contemplate these ideas, you can start to appreciate not just the mechanics of the universe, but also where you fit into its grand design. Einstein's own inquisitiveness about the cosmos is an open invitation for you to pose your own questions and carry on the exploration into the enigmas of space and time. The universe is a breathtaking place, teeming with wonders and mysteries. And one of the most compelling concepts in modern cosmology is the notion that it is continuously expanding. To understand what this expansion means, picture the universe as a vast balloon. As you blow air into it, every point on its surface moves farther away from every other point. This is analogous to our universe, which has been expanding since the moment of its creation, carrying entire galaxies away from each other. This leads to a fundamental question. What initiated this expansion, and how did a mind like Albert Einstein come to this very conclusion? During the early 20th century, as Einstein was developing his theory of general relativity, he encountered a significant problem. The dominant scientific belief at the time was that the universe was static and had remained unchanged throughout eternity. However, when he examined the gravitational equations at the heart of his theory, he saw they predicted a universe in motion, clashing with the comforting and widely accepted idea of a stable cosmos. Then, an astronomer by the name of Edwin Hubble made a monumental discovery that changed everything. He observed that galaxies were not only moving away from us, but that their speed of recession increased the farther away they were. This single observation completely overturned our understanding of the cosmos. If galaxies are all moving apart, It logically implies that in the distant past, everything must have been packed much more closely together, possibly originating from a single, infinitesimal point. So, what does this constant expansion of the universe suggest about your perception of time and space? The very idea that space itself is stretching implies that time might also be far more flexible than we conventionally believe, hinting that events across the cosmos are interconnected in ways we are just starting to unravel. The answer is an emphatic yes. Each new insight brings us a step closer to understanding the intricate arrangement of the vast cosmic ocean. Even so, Einstein wasn't immediately persuaded that an expanding universe was the definitive answer. In an effort to stabilize his model and align it with the static universe concept, he introduced what became known as the cosmological constant, an extra term in his equations. However, when the evidence for expansion became undeniable, Einstein famously referred to this constant as his greatest blunder, an admission that highlights his profound humility and commitment to the truth. The ongoing expansion of the universe doesn't just explain its past, it also sparks compelling questions about its ultimate destiny. If this expansion continues indefinitely, what will the cosmos look like billions of years from now? Will galaxies drift so far from one another that they disappear from our view entirely? Such thoughts force you to meditate on the long-term fate of the universe and your own existence within it. As our scientific understanding has progressed, we've learned that the universe is far from empty. It is filled with matter and energy interacting in highly complex ways. From this new perspective, two critical but mysterious components have come to the forefront: dark matter and dark energy. Although we cannot see dark matter directly, its existence is inferred from the gravitational effects it has on visible matter, telling you there's more to the universe than meets the eye. Dark energy is an even greater puzzle, believed to be the force responsible for the accelerating expansion of the universe. This makes you wonder just how much of reality is only the tip of the iceberg, and how many more secrets the cosmos is waiting to reveal. It is astounding to realize that Einstein's work laid the very groundwork for these modern investigations, with his insatiable curiosity inspiring countless scientists to follow. Ultimately, the expansion of the universe and its inherent complexity serve as a powerful reminder of how much is still left to discover. Science is a perpetually evolving field, where each new finding brings us closer to solving the grand mysteries of the cosmos. Human curiosity, exemplified by minds like Einstein's, remains the driving force that encourages you to look toward the heavens and question your place in this vast, expanding reality. The realization that we live in an expanding universe doesn't just alter our understanding of space and time. It prompts you to ask much deeper questions about the nature of existence itself. Our search for the truth is ongoing, and every new theory gives us a glimpse into the cosmic spectacle, reminding us that the unending quest for knowledge is a core part of what makes us human. For centuries, the concept of a static universe was the dominant view in cosmological thinking. From ancient Greek philosophers to scientists in the early 20th century, the consensus was that the universe was an eternal, unchanging stage. While stars and planets moved, their fundamental cosmic environment was thought to remain constant. So, what prompted Albert Einstein to challenge this long-standing belief? And what findings compelled him to reconsider everything known up to that point? Driven by a brilliant intellect and a relentless curiosity, Einstein immersed himself in the study of gravity and the fabric of space. When he introduced his theory of general relativity in 1915, he began to pave the way for a new cosmic perspective. Even so, the notion of a static universe remained fixed in his mind, leading him to formulate an equation that described a cosmos which neither grew nor shrank, simply because the alternative of a universe in constant flux seemed utterly preposterous at the time. Einstein's conviction in a static universe wasn't just a casual assumption. It was rooted in the logic and observational limits of his era, as there was no tangible evidence to suggest otherwise. This entire paradigm began to shift, however, with the work of Edwin Hubble in the 1920s. By studying distant galaxies, Hubble made the startling discovery that they were all moving away from each other, indicating that the universe was not static, but was instead a dynamic, constantly expanding system. This presented Einstein with a significant dilemma, as he had constructed a mathematical framework founded on the very idea of a static cosmos. How could he possibly align his theories with this contradictory new evidence? His solution had been the cosmological constant, a term he inserted into his equations specifically to allow for a universe that didn't move. In the wake of Hubble's discovery, however, Einstein conceded his error, and the constant he once viewed as a fix became an impediment to understanding the universe's true behavior. The idea of the universe as an inflating balloon offers a helpful visual. As it fills with air, any 2 points on its surface inevitably move farther apart. While Einstein initially imagined this balloon to be fixed in size, he eventually understood that it was, in fact, growing. This revelation didn't just alter his own views. It completely transformed the field of modern cosmology, opening up entirely new avenues of research and exploration. Despite his initial opposition, Einstein eventually accepted that his vision needed to be adaptable. Science, after all, is not merely about being correct. It is a process of learning and adjusting based on new information. This very ability to question established ideas and evolve is what gives the scientific method its incredible power. The story of Einstein and this static universe reminds you that even the most brilliant minds can be mistaken. His shift toward accepting an expanding cosmos also highlights the human element of scientific inquiry, the internal conflict between intuition and hard evidence. Scientists must frequently abandon deeply cherished beliefs when confronted with new data. While this process can be difficult, it is absolutely essential for the advancement of knowledge. Einstein's initial reluctance mirrors the universal challenge we all face when letting go of our certainties. But what is the real implication for you that the universe is expanding? It means that everything you know, from the most remote galaxies to your own existence, is in a state of perpetual motion. The concept of an expanding cosmos not only challenges your perception of reality, but also encourages you to reflect on your own life and your role on this immense stage. If the universe itself is so dynamic, perhaps we should be as well. Einstein's paradox and his belief in a static universe amount to more than just a chapter in science history. They demonstrate that science is a journey of discovery, often filled with unpredictable twists. They serve as a reminder that curiosity and the courage to ask fundamental questions are crucial for making progress. In facing his own uncertainty, Einstein left behind a legacy that continues to motivate generations of scientists and thinkers. Ultimately, the evolution of Einstein's perspective from a static model to a dynamic, expanding one is a profound lesson in the value of intellectual flexibility. Science constantly pushes you to adapt and grow, and this journey of discovery is truly without end. Just as the universe expands, so will our comprehension of it, forever inviting us to venture beyond the boundaries of the known. As we explore deeper into the cosmos, it's important for you to remember that every solution gives rise to new questions, and each discovery brings us a step closer to unraveling the mystery of our own existence. Have you ever thought about how the equation describing our universe is actually put together? One of its most fascinating elements is the cosmological constant. But what is this constant, And why did Albert Einstein consider it so vital? The cosmological constant can be seen as a clever mathematical device that Einstein chose to embed within his celebrated equations of general relativity. Imagine you are inflating a balloon. As you blow into it, its surface stretches and expands. Applying this analogy to the cosmos, you might assume that everything within it is also moving apart. However, Einstein was not entirely convinced of this, and early in his career, held the belief that the universe was motionless and had existed forever. He came to realize, however, that this idea didn't quite mesh with what his mathematics were suggesting. The cosmological constant was his inventive attempt to counteract gravity, which pulls everything together, with an opposing force that pushes everything apart. It was like trying to achieve a perfect state of equilibrium on a scale. To balance gravity's immense downward pull, he needed an upward push, something to keep the entire universe from collapsing in on itself. But what exactly was this force? The solution was identified as the cosmological constant. You can think of this constant as a type of unseen vacuum energy. Einstein theorized that a force operating in the void of space was driving galaxies apart. To help you picture this, imagine the universe is an enormous ocean, with the cosmological constant acting as the wind that moves the waves. In its absence, galaxies would be locked in a constant pull toward the center, as though caught in a gravitational snare. The notion of a cosmological constant, however, was not met with easy acceptance. When it was confirmed that the universe was genuinely expanding, Einstein felt a measure of embarrassment for ever proposing it, famously labeling it his single greatest blunder. Yet, was it truly a mistake? In time, the cosmological constant found its way back into modern cosmology, particularly as new theories concerning dark energy began to surface. Dark energy is the term for the enigmatic force that seems to be speeding up the universe's expansion. This is precisely where the cosmological constant re-enters the picture, as a majority of scientists now see it as a fundamental element of this acceleration. It's remarkable to realize that an idea Einstein himself dismissed as a failure has become a cornerstone of how we currently understand the cosmos. Let's envision the universe as a massive balloon that is continuously being inflated. While gravity works to make it shrink, dark energy, which is represented by the cosmological constant, persistently pushes outward, preventing the balloon from collapsing. This fine balance is absolutely essential for the stability of our cosmos. The consequences of this constant are immense. If this vacuum force is powerful enough, it could result in a future where the universe expands forever, scattering all galaxies until they become isolated islands in a boundless sea of empty space. This is a rather sobering concept, but also an incredibly exciting one, because it forces us to contemplate the eventual destiny of everything that we know. For many years, the cosmological constant has been the focus of intense scientific study. As researchers continue to probe the cosmos, their work uncovers more information about the nature of this constant and its function in cosmic expansion. The pressing question for many now is whether our grasp of the cosmological constant is still in its earliest stages. Every new discovery seems to generate even more questions. Is it possible that other, as yet unidentified forces are at play throughout the universe? And what part will they have in shaping our comprehension of the cosmos in the coming years? The cosmological constant demonstrates that the universe is a place filled with secrets, and that scientists act like detectives, piecing together clues to figure out how it all works. Therefore, this constant is far more than a simple number in a formula. It stands as a powerful reminder that our conceptions of the universe are in a constant state of evolution. It is human curiosity that compels us to continue exploring, to persist in asking questions, and to never stop searching for answers. You can only guess what else we might learn in the future about this constant and how it connects to the cosmos. Every answer we uncover only leads to new inquiries, and this is what makes the scientific endeavor so thrilling. The history of the cosmological constant offers a lesson in humility for every one of us, showing that even the most brilliant minds, like Einstein, can revise their thinking as our collective knowledge grows. So, the next time you gaze up at the night sky, keep in mind that there is more going on than what you can see, and that a great deal remains to be discovered in our vast and mystifying universe. When we observe the starry sky, a fascinating question naturally comes to mind. How did all of this begin? The pursuit of an answer to that question brings us to one of the most transformative theories in modern cosmology, the Big Bang. This model, which outlines the origin of our universe, has not only transformed our understanding of the cosmos, but has also challenged our fundamental ideas about space and time. To grasp the Big Bang, it's crucial to understand that at the very beginning, the entire universe was an unimaginably tiny and dense point, known as a singularity. What does that truly signify? Try to picture every atom, every star, and even the vast emptiness between them all concentrated into a single speck, as if an entire library's contents were squeezed into just one book. Then, suddenly, this point began to expand, and from this expansion, the universe, as we perceive it, started to emerge. So how did Albert Einstein become involved in this narrative? While his theory of relativity was an incredible accomplishment, he was not the originator of the Big Bang concept. Despite this, his work provided the essential groundwork for other scientists to investigate the possibility that the universe is not static, as was commonly thought, but is instead in a state of continuous movement and transformation. This idea fundamentally disrupted the traditional view of the cosmos and paved the way for new theories. One of the most compelling questions that arises is this: if the universe has been expanding ever since its birth, what lies beyond the edge of this expansion? To help us comprehend this idea, cosmologists often use analogies. Imagine you have a balloon. As you inflate it, any marks drawn on its surface will spread further apart from each other. In a similar way, galaxies are moving away from one another as the fabric of the universe itself expands. This isn't merely a theoretical idea. It's a phenomenon that has been observed and measured, compelling us to accept that the universe is constantly growing. Now, amid all this cosmic mystery, another question emerges. What is Einstein's specific link to the Big Bang? Although he didn't formulate the theory himself, his general relativity equations described how gravity shapes the very structure of the universe. Within these equations, Einstein had included his cosmological constant, which he initially believed would allow for a static cosmos. However, upon the discovery that the universe is expanding, he concluded he had made an error. That very error, in a twist of fate, became a pivotal step toward understanding the Big Bang, the universe's evolution, and even our modern conception of time itself. If the Big Bang truly marks the genesis of time as you perceive it, then what could have possibly come before? Some scientists propose that your very concept of time might be constrained, suggesting that time itself may have ignited in that first moment of expansion. A thought that opens up deep philosophical inquiries into the essence of existence. A truly remarkable aspect of the Big Bang is that you can still observe its aftermath in the cosmos today. The cosmic microwave background, also known as relic radiation, is a pervasive thermal energy that fills the universe, serving as the lingering heat signature from that initial cosmic event. This radiation acts as a faint, universal echo, conveying information about the universe's first moments and giving scientists a way to investigate its history. Doesn't it fill you with wonder to realize that when you gaze at the night sky, you are witnessing not just stars, but also the ancient remnants of an event that unfolded billions of years ago? The Big Bang is also fundamental to your understanding of how galaxies and larger cosmic structures came into being. As the universe stretched outwards, gravity caused matter to coalesce, giving rise to the very first stars and galaxies, demonstrating how this familiar force plays a pivotal role in cosmic evolution. Without gravity, the universe might have remained a formless, chaotic void. In more recent times, scientists have learned that the universe is not merely expanding, but that its expansion is actually accelerating. This discovery points to the existence of dark energy, an enigmatic force that appears to be fueling this accelerated growth, even though its true nature remains one of cosmology's greatest unanswered questions. As you delve deeper into the universe's mysteries, you also encounter dark matter, a type of matter that is completely invisible because it doesn't emit any light. Its presence is inferred only through its gravitational effects on the movement and clustering of galaxies. Together, dark matter and dark energy represent fundamental components of the cosmic puzzle, essential for explaining how the universe functions on the largest scales. Exploring the Big Bang is more than a scientific endeavor. It is an invitation for you to contemplate your own position within the cosmos. This knowledge reminds you that you are a part of an immense universe with a history stretching back for billions of years. This realization naturally leads you to wonder about the future. Will the universe continue expanding indefinitely, or will gravity eventually reverse the process, leading to a cosmic collapse? Ultimately, when you reflect on the Big Bang and all its implications, it is hard not to feel humbled by the sheer vastness of space, while also feeling profoundly linked to it. The narrative of the universe is, in a way, your own story, a saga of creation, expansion, and continual transformation. As you persist in exploring and discovering, you move closer to comprehending not just the cosmos, but also your own place within this magnificent and mysterious setting. The cosmic microwave background radiation stands as one of the most profound discoveries of the 20th century. To grasp what it is, picture yourself standing in a dark room when a light is suddenly switched on. Instantly, the void is filled with a soft luminescence. That faint light, however dim, proves the existence of something you were unable to see moments before. The cosmic microwave background essentially serves as this kind of illuminating glow for the entire universe, enabling you to look back into its distant past. Its significance was cemented in 1965, when two scientists named Arno Penzias and Robert Wilson were working with a radio telescope in New Jersey. They kept detecting a persistent, low-level noise in their data, a kind of whisper that came from every direction they pointed their instrument. They initially suspected it was some form of interference, but they came to understand that this sound was, in fact, the actual echo of the Big Bang, providing the first solid proof of the universe's explosive birth. Consider the universe to be like a balloon you are inflating. The air inside it expands uniformly in all directions. The cosmic microwave background is a remnant of this cosmic expansion, a faint light that can be seen from everywhere in space. Its temperature is now approximately 2.7 Kelvin, representing the cold afterglow of that primordial moment when all energy was concentrated into a single point. This radiation doesn't just tell you about the universe's past, it also reveals how it has cooled and expanded over billions of years. Can you fathom looking through a telescope and seeing not only stars, but the literal history of the cosmos unfolding before you? That is precisely what the cosmic microwave background lets you do. Although this radiation is composed primarily of microwaves, you can think of them as the ambient music of a cosmic orchestra. Each frequency represents a different period in the universe's timeline, as the initial light and energy cooled and stretched into the microwaves that are measurable today. The cosmic microwave background also contains detailed patterns that hold information about how matter was originally distributed throughout the early universe. Think of it as an ancient map where the faint outlines of mountains and valleys are still visible. This radiation is a celestial map of sorts, showing the slight density variations in primordial matter that eventually led to the formation of all the galaxies and cosmic structures you observe today. One of the most fascinating qualities of this relic radiation is its near-perfect uniformity. While it appears incredibly smooth at first glance, a closer look reveals minuscule fluctuations in temperature. These tiny variations are like the first brushstrokes on a vast cosmic canvas, marking the spots where gravity would begin to pull matter together from the primordial soup of particles. These subtle differences, imperceptible to the naked eye, hold the secret to how the entire universe organized itself over eons. As researchers delved into the cosmic microwave background, they began to reveal profound truths about the universe's makeup. This ancient radiation led to a startling realization. The vast majority of the cosmos is composed of elements you cannot see, namely dark matter and dark energy. While these components are not part of the radiation itself, their gravitational effects are imprinted on its distribution throughout the heavens. The cosmic microwave background also proved indispensable for validating the cornerstones of modern cosmology. There was an extraordinary correspondence between the predictions of the Big Bang model and the actual observations of this relic radiation. This alignment provided scientists with a dependable theoretical foundation for charting the evolution of the universe. Of course, the picture is far from complete, and significant questions persist. What precisely transpired during the universe's initial moments? What sequence of events gave rise to this faint radiation that you and I can now detect? Every breakthrough seems to present new puzzles, and the cosmic microwave background serves as a potent reminder of both how much we have learned and how much more remains to be discovered. As you continue to investigate the cosmos, you find that the cosmic microwave background does more than just narrate the universe's history. It prompts you to consider your own place within that epic story. You are an integral part of a timeline that extends across billions of years. Examining this radiation gives you a chance to form a deep and significant connection with the cosmos itself, making it more than a simple measurement. It is a conduit to our shared cosmic origins. This ancient signal invites you to gaze into the distant past and contemplate what lies ahead. So, the next time you look up at the star-filled night sky, remember that you are also sensing an echo of the Big Bang. It is a whisper from the dawn of time, reverberating through space and guiding you on your unending quest for knowledge and understanding. Gravity is one of those pervasive forces that you encounter everywhere. But have you ever stopped to think about how it shapes the formation of galaxies and large-scale structures in the universe? From a single apple dropping from a branch to the magnificent clusters of galaxies, gravity is the master architect of cosmic organization. But what does that truly imply for the universe's structure and for you? To grasp its impact, you can picture the universe as an immense canvas, with galaxies, stars, and planets being the elements painted upon it. In this analogy, gravity is the artist's brush, linking all these components together to form the intricate patterns and structures you observe. In a universe devoid of gravity's influence, chaos would reign, with stars drifting aimlessly and galaxies never coming into existence. The key to gravity's power is its inherent ability to attract matter. Any object possessing mass exerts a gravitational pull on every other object. Much like a heavy bowling ball draws lighter pins toward it, stars and planets pull other celestial bodies into their orbits. This is the very phenomenon that binds galaxies together across the unimaginable voids of space. But what occurs when this gravitational dance involves numerous objects? The interplay among multiple celestial bodies generates a phenomenon we call collective gravity. You can think of it like a crowded event where people are mingling. Some individuals might draw others into their circle, creating small groups. In a similar fashion, galaxies assemble into clusters, bound by the mutual gravitational forces that keep them connected. Within individual galaxies, gravity's work becomes even more intricate. These massive structures are not just haphazard assortments of stars and dust. Instead, gravity orchestrates the concentration of gas and dust into specific regions, which then become the birthplaces of new stars. This process functions like a colossal cosmic factory, where gravity gathers the raw materials needed to forge something luminous and new. Once these new stars ignite, they profoundly affect their local environments. The most massive stars emit powerful radiation and stellar winds that can either disperse surrounding gas or trigger the collapse of other clouds to form yet more stars. It is a perpetual cycle of cosmic creation and destruction, all driven by the fundamental laws of physics. At the most extreme end of gravity's influence, you find black holes. These are regions of spacetime so incredibly dense that their gravitational pull is inescapable, even for light itself. A black hole is born when a massive star depletes its nuclear fuel, causing its core to collapse under its own immense weight. The presence of these objects fundamentally alters the galaxies they inhabit. Supermassive black holes, which are found at the heart of most large galaxies, appear to regulate the growth and evolution of their galactic hosts. Researchers have identified a distinct relationship between the mass of a galaxy's central black hole and its total number of stars. This finding suggests that these enigmatic objects play a vital role in controlling the pace of galactic development. As the universe expands, gravity continues to be a defining force in the large-scale distribution of cosmic structures. While the expansion pushes galaxies apart, gravity acts as a powerful counterforce, pulling them back together. This cosmic tug-of-war is what sculpts the universe into a stunning tapestry of filaments and voids. So, what do these cosmic patterns suggest about the universe's future? As the expansion continues, gravity may face an insurmountable challenge from dark energy, the mysterious force believed to be accelerating this expansion. This raises the question of whether gravity will eventually lose its role as the primary shaper of cosmic structures. Scientists are actively working to understand this complex interplay and what it means for the ultimate destiny of our universe. Grasping how gravity shapes the formation of galaxies and cosmic structures is more than just an intriguing exercise. It helps you understand your own position within the cosmos. Every star, galaxy, and black hole is an integral part of an immense, interconnected web that has been evolving for billions of years. Though it remains unseen, gravity is the fundamental architect of our universe, serving as a constant reminder that you and I are part of something immeasurably vast. So, the next time you gaze up at the night sky, consider that the very same force holding Earth in its orbit also binds every single star you see. Gravity is far more than a simple physical law. It represents one of the primary keys to unlocking the secrets of the immense and enigmatic universe we inhabit. This ongoing search for answers continues as the story of gravity and its cosmic influence is still being written. Have you ever had the feeling that something imperceptible is all around you? An invisible presence that nonetheless affects everything in your environment? That is precisely the sentiment shared by the scientific community in its efforts to decode the mysteries of dark matter and dark energy. We are certain that dark matter exists, despite our inability to see it, and its impact is absolutely essential for comprehending the mechanics of the universe. Think of dark matter as an invisible halo that envelops galaxies. While your eyes can perceive stars and planets, there is something more profound holding it all together, a substance we cannot directly observe. Scientists calculate that approximately 85% of all matter in the cosmos is dark matter. Although it neither emits nor reflects any light, its existence is confirmed by the gravitational pull it exerts on the visible matter we can detect. To help you visualize this, imagine that galaxies are like great ships navigating a boundless ocean. In this analogy, dark matter is the very water that supports them and keeps them intact, preventing them from simply drifting apart. So what is this substance, really? For a better grasp, picture yourself in a busy park. You see all the people moving around, but you are also aware of unseen elements, such as the air you depend on to breathe. In a similar fashion, dark matter serves as the invisible framework that connects and sustains entire galaxies, guiding their motion and structure. Dark energy, however, presents an even more profound puzzle. Picture the universe as a balloon that is not just expanding, but expanding at an ever-increasing rate. You might initially assume that the air being forced inside is the sole cause of this growth. In reality, a mysterious force is actively accelerating this expansion. That force is what we call dark energy, and it is thought to constitute around 70% of the total energy in the universe, providing the only explanation for why cosmic expansion is speeding up. To understand why dark energy is so crucial, consider a car that is accelerating down a road. If the engine were to cut out, you would expect the car to slow down and eventually coast to a stop. But what if an unseen force kept pushing it, causing it to go faster and faster? This is precisely what dark energy does for the universe. It acts as the engine driving it to expand at a rate that defies initial expectations. Let me explain how scientists even reached such a conclusion. During the mid-20th century, astronomers observing distant galaxies noticed something baffling. Despite the relentless pull of gravity, which should have been slowing the universe's expansion, these galaxies were actually moving away from each other at an accelerating speed. This startling observation demanded an explanation, and dark energy emerged as the most viable answer to this cosmic riddle. These concepts of dark matter and dark energy are not merely fascinating theories. They compel you to fundamentally reconsider everything you thought you knew about the universe. If all the matter we can see and measure accounts for just a tiny fraction of what truly exists, what other secrets might the cosmos be concealing? It is as if we are only witnessing the very tip of an enormous iceberg, with the vast majority hidden from our view, prompting us to question our entire understanding of reality. The implications of these ideas are truly staggering. If these invisible components are the foundational structure of our universe, what does that mean for you and me? Are there unseen forces that are actively shaping the reality we experience every day? This quest for answers is propelling us toward new frontiers of both science and philosophy, as researchers devise new experiments to finally detect dark matter and comprehend the true nature of dark energy. The connection between dark matter, dark energy, and Einstein's theory of relativity is absolutely vital. Einstein revealed that gravity isn't a force in the traditional sense, but rather a curvature in the very fabric of spacetime. Dark matter directly influences this curvature by adding mass, while dark energy is intrinsically linked to the dynamics of spacetime's expansion. these concepts are intertwined in complex ways that we are only just starting to unravel. As science advances, so does our comprehension of the cosmos. Dark matter and dark energy stand as two of the greatest challenges confronting us today, where each new discovery seems to generate even more questions, beckoning us to continue our exploration. Ultimately, contemplating these immense mysteries forces you to reflect on your own place in this vast, unfolding drama. Will we ever uncover all the secrets the universe holds? Only time will tell, but the pursuit of that knowledge is every bit as thrilling as the final destination. What would you think if I were to tell you that Albert Einstein's theories didn't just revolutionize our view of time and space, but that they continue to be a guiding force in modern cosmology? Relativity, the celebrated theory that gave us an entirely new way to perceive the universe, remains the bedrock upon which our modern understanding is built. But how can a set of ideas, formulated over a century ago, still hold such profound relevance today? You can think of relativity as a kind of master key, a guide that doesn't just show you a location in the cosmos, but explains the fundamental rules of how everything moves through it. Trying to comprehend how objects behave in the cosmos without relativity would be like navigating a vast ocean with no compass. In essence, relativity serves as the very instrument that guides us through the universe's profound mysteries. One of Albert Einstein's most remarkable contributions to modern cosmology was his genius for uniting concepts that appeared to be completely separate. You might ask, how are space and time interconnected, and what part does gravity play in this cosmic scheme? These are central inquiries in cosmology, and because of Einstein, we now have a completely new framework for addressing them. His theory revealed to us that time is not an unchangeable constant. Instead, it can dilate or contract based on the velocity of our movement. This realization forces you to question the fundamental nature of time itself. Is it a linear progression or an endless cycle? The general theory of relativity expanded upon this by presenting the notion that gravity is not simply a force, but a distortion in the very fabric of spacetime. This groundbreaking concept prompts you to consider how gravity influences the massive objects scattered throughout the universe. To help you visualize this, think of a stretched trampoline. If you set a heavy ball in its center, the material curves downward, forming a dip. Any marble you roll near that depression will naturally be drawn toward the heavier ball. This is a simple analogy for how gravity operates in the cosmos, orchestrating an intricate dance among celestial bodies. Yet, relativity is far more than a theoretical construct. Scientists have verified many of Einstein's forecasts through rigorous experiments and careful observations. For instance, when you examine the motion of stars in far-off galaxies, you can actually see the effect of gravity on their paths. This brings up another compelling question. How can we be certain that relativity is accurate and not just an elegant theory? The proof is found in the way scientists have used it to foretell the universe's behavior, from the bending of light around immense objects to the slowing of time near a black hole. Each of these verified observations reinforces Einstein's ideas, making you marvel at the possibility that one person's mind could so accurately predict the mechanics of stars and planets. As our understanding of cosmology has matured, it has become apparent that relativity is crucial for grasping phenomena such as the expansion of the universe. The very idea that the cosmos is growing was, in part, made possible by Einstein's equations, and without his insights, we might still be stuck with a static model of reality. But how do we know for sure that the universe is expanding? We've witnessed the redshift of distant galaxies, which signals that they are moving away from us, a phenomenon that perfectly aligns with Einstein's concepts about the stretching of space itself. Following this line of thought, you cannot overlook relativity's impact on our comprehension of dark matter and dark energy. These concepts, which can feel quite abstract, are deeply interwoven with Einstein's theories. You may wonder how it is that something we can't even see exerts such a tremendous influence on the structure of the cosmos. Relativity offers the essential framework needed to investigate these questions, enabling scientists to create models that explain how dark matter and dark energy drive the universe's expansion. Without his contributions, these ideas might have stayed forever hidden from our understanding. Furthermore, relativity has laid the groundwork for entirely new theories, including the ongoing quest for a unified theory that would merge gravity with the other fundamental forces. Our innate curiosity about the universe compels us to explore ideas like string theory and the multiverse, a theoretical ensemble of all conceivable universes, which often build upon the principles of relativity. This makes you wonder if we are on the cusp of even greater discoveries about the universe's true nature. Einstein's legacy in modern cosmology is simply undeniable. His work has not only revolutionized our view of the cosmos, but has also motivated generations of researchers to keep exploring and questioning. As we consider the immense role of relativity in cosmology, it's clear its principles were foundational to unlocking the universe's secrets. You have to ask, what other enigmas are waiting for us? And what part will Einstein's theories play in the future of science? The search for answers is ongoing, and every new question moves us closer to understanding the vast and magnificent cosmos we call home. Black holes stand out as one of the most captivating and mystifying phenomena in the universe. But to truly grasp what they are, you could think of them as a sort of cosmic vacuum cleaner, formed when an incredibly massive star burns through its fuel and collapses under its own gravitational force. This collapse can become so extreme that nothing, not even light, can break free from its grasp, which establishes a boundary known as the event horizon. It is at this point that the true wonder and mystery take hold, as it marks a region where the laws of physics as you and I understand them simply break down. The connection between Einstein and black holes is both profound and intricate, as his theory of general relativity, which completely reshaped our understanding of gravity, actually predicted the existence of these cosmic enigmas. He achieved this by describing gravity not as a force but as a curvature in spacetime, giving us a novel way to picture how mass affects its surroundings. Revisiting the trampoline analogy, a bowling ball placed on the surface causes it to sag, creating a well. If you then roll a smaller marble nearby, you'll observe it spiraling into that depression. This is precisely how a black hole's gravity draws in everything in its vicinity. It's fascinating to note that even though Einstein was the pioneer of this concept, he personally harbored doubts about whether black holes could truly exist in the real world. At the time, Einstein regarded these outcomes of his equations as little more than mathematical peculiarities. Yet, with the march of science, subsequent discoveries verified that these cosmic objects were real. Can you fathom the sheer amazement of astronomers when they uncovered proof of supermassive black holes lurking in the centers of countless galaxies, ours included? Consider the singularity found at the heart of a black hole. This is a zone where density escalates to infinity, and the physical laws that we understand completely collapse. Try to picture this. It is essentially like attempting to crush a whole mountain down to the scale of a single atom. As you draw nearer to the singularity, space-time begins to act in very peculiar ways. Time itself can seem to decelerate, while the gravitational pull intensifies to such an extreme that it can warp our very sense of reality. If that notion seems frightening, that's because it truly is, but it is also exceptionally thrilling. Despite their reputation for destruction, black holes are absolutely essential to our comprehension of the cosmos. It's widely thought that they have a crucial function in the creation and development of galaxies. How can an object so bizarre and ravenous be so indispensable? The solution is found in the immense energy they emit, like the powerful bursts of X-rays from matter being pulled in. This leads to a fascinating thought. What would occur if you got close to a black hole? Should you find yourself unfortunate, or perhaps fortunate enough to be near one, you would undergo a process known as spaghettification. This strange term perfectly captures how gravitational forces would simultaneously stretch and squeeze you, transforming your body into something like a strand of spaghetti. Moreover, black holes are not isolated events. They function within a vast cosmic ecosystem. In fact, it is believed that the universe contains more black holes than it does stars. Can you envision a cosmos populated by these entities, each one capable of consuming matter and growing in mass, thereby powering a continuous cycle of cosmic birth and death? Modern science has progressed to where we can now indirectly observe black holes. A prime example occurred in 2019, when the very first photograph of a black hole in the Messier 87 galaxy was taken. Just think about the emotions of those scientists. Witnessing that image was like seeing an age-old myth materialize, providing a stunning confirmation of Einstein's theoretical work. Nevertheless, a great deal still awaits discovery. Enigmas like what truly exists past the event horizon, or if escape from a black hole is even possible, are still without answers. Certain theories propose the existence of space-time conduits called wormholes that could link disparate regions of the universe. But are these real possibilities, or just the domain of science fiction? With advancing technology, our telescopes and satellites are collecting unprecedented amounts of data, enabling us to probe these celestial riddles more deeply. The insatiable nature of human curiosity and our drive to comprehend the unknown compel us to constantly investigate and ask questions. What incredible insights about black holes and their universal role does the future hold for us? So, when you contemplate black holes, see them not merely as cosmic vacuum cleaners, but as vital pieces in the grand puzzle of the universe. They serve as a powerful reminder of just how much we have yet to learn, and how human ingenuity can solve even the most profound of mysteries. The sheer complexity of black holes calls on us to gaze beyond our own world and venture into the immense and uncertain expanse of the cosmos. One of the most captivating and intricate concepts in contemporary physics is string theory. But what exactly is it, and why should you find it important? To grasp this, you must first remember that the universe we experience is composed of minuscule particles that interact with one another. The problem is that traditional particle models have hit a wall in the quest for a single, unified theory that can account for all of nature's forces. This is the point where string theory makes its entrance. Picture every fundamental particle not as a tiny dot, but as a vibrating filament, much like a string on a guitar. Different vibrations of these strings produce different particles, just as a guitar string produces different notes. This suggests that all matter and energy could be the product of these tiny, oscillating strings, an idea that is truly mind-boggling to consider. While string theory might initially sound like pure fantasy, its genuine appeal lies in offering a potential bridge between Einstein's theory of relativity and quantum mechanics. Ever since Einstein developed his theories, physicists have been trying to create a single framework that unifies gravity with the nuclear and electromagnetic forces. String theory just might be the master key that locks all of physics into one elegant, unified whole. So how does this all circle back to Einstein and his contributions? Einstein showed us that gravity could be understood as the warping of spacetime's geometry. String theory expands on this by proposing that space itself contains more dimensions than we are capable of perceiving. Our world appears to have 3 spatial dimensions and 1 of time. But string theory posits that there are extra dimensions, possibly folded up so tightly that they are invisible in our daily lives. Can you wrap your head around a universe with more dimensions than you can directly experience? The notion of these hidden dimensions is not just fascinating, it opens up a host of profound questions about the nature of our universe. These extra dimensions could potentially hold the secrets to phenomena that currently defy our explanations, from the fundamental nature of gravity to the very flow of time, suggesting there is so much more for us to uncover. In many ways, string theory positions itself as a potential theory of everything, but confirming its validity presents an enormous challenge. The staggering energy levels at which these hypothetical strings vibrate make direct experimental verification nearly impossible with our current technology. This creates a genuine paradox. How can you be certain a theory is correct if its core principles cannot be directly observed? To solve this, scientists are turning to creativity and innovation, seeking indirect evidence such as supersymmetric particles, which are a direct prediction of the theory. Imagine the excitement that would follow the discovery of a new particle that proves all this theoretical work was right. The implications of string theory reach far beyond academic curiosity, profoundly affecting your very understanding of reality. If the cosmos is built not from separate particles but from vibrating filaments of energy, then your perception of the world is likely far richer and more complex than you have ever considered. This realization prompts you to reflect on your own existence and your place within the vastness of the cosmos, forcing you to ask what it means to be part of a universe where everything is interconnected by these fundamental vibrations. Of course, like any revolutionary idea, string theory faces its share of criticism. Some in the scientific community argue that it is overly speculative and lacks the backing of reliable empirical data. Despite this skepticism, the intrinsic beauty of its mathematical framework, along with its capacity to unify seemingly unconnected concepts, continues to compel many researchers to explore its possibilities. This serves as a reminder that in science, the most transformative breakthroughs often originate from imagination and inspiration. As we persist in studying and exploring the fundamental nature of the universe, string theory acts as an invitation to think bigger and challenge everything you assume to be true. It pushes you to consider that your current comprehension of physics might only represent the very tip of the iceberg. This makes you wonder what other astonishing secrets the universe might be waiting to reveal, if only you have the courage to look beyond the limits of your current knowledge. The concept of the multiverse has seized the imagination of scientists and philosophers alike. But what exactly is it? The proposition that our own universe could be just one among countless others is as perplexing as it is captivating. You can picture it as a cosmic ocean filled with bubbles, where each bubble constitutes a separate universe governed by its own distinct physical laws and its own unique reality. But what led us to this idea of a multiverse in the first place? While Albert Einstein never directly theorized about it, his work established the essential groundwork that allowed others to explore the concept. His theories of relativity taught us that spacetime is not a fixed, rigid stage, but a flexible fabric, which opened a conceptual pathway to the possibility of multiple realities. If space and time can bend and warp, then it is a logical next step to ask why there couldn't be other universes with entirely different configurations.
You should consider the possibility of parallel universes, where perhaps you made a different choice at a crucial juncture in your life. Maybe another reality exists where the dinosaurs were never wiped out, or one where human technology never emerged. While this may sound like science fiction, scientists are genuinely working to figure out how it could be possible. String theory, which is widely explored by theoretical physicists, supports this by suggesting that elementary particles are vibrating strings
that can exist in more than 3 spatial dimensions. This framework makes the multiverse seem less abstract and more tangible, prompting the question, if strings can vibrate in different ways, what other realities could they create? One of the most intriguing aspects is that if multiple universes do exist, each one could have different physical constants. What would occur in a universe with weaker gravity or a different speed of light? The potential variations are truly endless. This leads to a fundamental question about our own existence. Why does our universe possess the specific properties it has? Perhaps it is because ours is simply one of a vast number where the conditions happened to be just right for life as you know it. Cosmologist Max Tegmark has even categorized potential multiverses, ranging from those with minor variations to ours to those with completely different laws of physics, providing a speculative but organized approach to the idea.
The multiverse also brings up deep philosophical questions about your place in existence. As a conscious individual, what does it mean to learn that you might be just one small part of an immense landscape of universes? This notion can feel incredibly liberating, but it could also make you feel profoundly insignificant. The possibility that other universes are real has the power to reshape your entire understanding of life's purpose and meaning.
Nevertheless, the idea of the multiverse is not without its detractors. Many scientists argue that because the concept is so difficult to either prove or disprove, it rests on the boundary between science and pure philosophy. If another universe is completely separate from our own, how could you ever begin to study it? This is one of the most significant challenges that theorists who support the multiverse must confront. Despite these scientific challenges, the multiverse has become a rich source of inspiration for countless works of literature, film, and art. Popular movies and television shows have brought the idea of alternate realities and parallel universes to a wide audience. This exposure helps make a complex and often distant-seeming area of science feel more accessible and engaging for you. In this context, Albert Einstein's work retains its extraordinary relevance. His courage in challenging conventional views of space and time paved the way for subsequent generations to consider radical ideas like the multiverse. So, while Einstein himself did not propose the existence of other universes, his intellectual legacy continues to inspire scientists to explore these fascinating concepts. Contemplating the multiverse forces you to question your understanding of the cosmos and reflect on your place in a possibly infinite array of realities, leaving you to wonder if you are alone or part of something much larger and more complex than you ever imagined. As our exploration of cosmic questions continues, the concept of the multiverse serves as a powerful reminder that human curiosity is truly limitless. Every new theory and discovery inches us closer to grasping the sheer scale of the reality that surrounds us, confirming that the quest for knowledge is an unending journey, where each solution only uncovers new mysteries. The very notion that our existence might be just one among countless universes opens up an exhilarating new frontier for thought. Science has consistently served as our guide into the unknown, and the multiverse is simply one of the latest enigmas we have yet to solve. So, what kind of future is in store for us within this immense and cryptic reality we call the universe? The answer likely lies just beyond our current reach, waiting for its moment of revelation. You might wonder what tool enabled scientists to comprehend the universe's true vastness. That key is found predominantly within the theories of Albert Einstein. Over the decades, a wide array of experiments has substantiated his concepts, solidifying his legacy within the foundations of modern science. But how exactly were these revolutionary ideas validated in the realm of cosmology? The answer to that is both intricate and captivating. One of the most celebrated experiments that affirmed Einstein's theories occurred during the solar eclipse of 1917. For this event, British astronomers journeyed to strategic vantage points to witness how light from distant stars warps as it passes close to the Sun. This very phenomenon, which Einstein had predicted in his theory of general relativity, showed that gravity influences not just physical objects, but light itself. The validation of this effect was a defining moment that earned Einstein worldwide recognition. But what about the evidence for an expanding universe? In 1929, the astronomer Edwin Hubble utilized a telescope on Mount Wilson to study faraway galaxies. Through an analysis of the light emanating from them, he found that they were all receding from us, which was a clear sign that the universe is expanding. This discovery, which perfectly matched Einstein's concepts of a dynamic cosmos, served as a direct endorsement of his work. It's truly remarkable to consider how Einstein's theories set the stage for discovering the evolving nature of our universe. The cosmological constant is another piece of this puzzle that commands our attention. Einstein originally added this variable to his equations to accommodate a static universe, which was the accepted view at the time. Yet following Hubble's discovery, Einstein famously renounced the constant, labeling it his single greatest blunder. In a fascinating reversal, however, this same constant has found new importance in contemporary cosmology, particularly for explaining the universe's accelerating expansion. How is it that an idea once discarded as a mistake is now deemed so crucial? Experiments involving supernovae have also delivered compelling proof for the accelerated expansion of the cosmos. In 1998, two separate astronomy teams, one based in the United States and another in Australia, observed that distant supernovae were dimmer than they should have been. This finding led them to a peculiar conclusion. The universe is not merely expanding, but its expansion is speeding up, a phenomenon that became strong support for the concept of dark energy. Black holes constitute another thrilling field of study, where Einstein's ideas have been proven correct. His theory of general relativity predicted the existence of these enigmatic celestial objects, and today we have directly observed their impact on the cosmos. The event in 2019, which produced the first-ever image of the black hole at the center of the Messier 87 galaxy, represented a truly historic milestone. Isn't it incredible to think that we can now see something that Einstein envisioned over a century ago? Furthermore, experiments focused on gravitational waves, those ripples in spacetime generated by massive cosmic events, have also corroborated Einstein's theory. In 2015, the LIGO collaboration made the first-ever detection of these waves, a phenomenon Einstein had foreseen decades earlier. This breakthrough initiated a new era in astronomy, granting us the ability to perceive the universe in ways that were previously unimaginable. Particle physics, particularly through experiments conducted at accelerators like the Large Hadron Collider, also reinforces Einstein's theories. By examining the fundamental particles that compose our reality, scientists have uncovered evidence that supports the notion of gravity as one of the most basic forces, just as Einstein proposed. Who would have guessed that the hunt for the tiniest particles would ultimately validate the ideas of a man who thought on the grandest possible scale? What's perhaps even more astounding is the way Einstein's concepts have shaped our modern technology. From the satellite navigation systems you use daily to advanced medical imaging, the theories of relativity have a direct and profound effect on our lives. Have you ever stopped to think about how satellites deliver a precise location to your phone? The principles of relativity are absolutely vital for that to work. And without Einstein, our technological landscape would look entirely different. The relationship between quantum theory and relativity has been yet another research area filled with numerous experiments. Although Einstein held personal reservations about quantum mechanics, his work was instrumental in the field's development. Current studies into quantum entanglement, the mysterious link between particles separated by vast distances, are just one demonstration of how his theories continue to be relevant and inspiring today. As you explore these varied experiments, it becomes obvious that Einstein's work has not only been confirmed, but has also served as a catalyst for new questions and groundbreaking discoveries. The way his theories have unlocked a more profound comprehension of the universe stands as a testament to his extraordinary genius. One can only wonder what other cosmic secrets are out there, waiting to be revealed by inquisitive minds who dare to challenge what is already known. From the way light bends to the very expansion of the cosmos, his perspective has profoundly shaped every aspect of modern cosmology. As our journey into space continues, Einstein's theories serve as our constant guide in the quest for understanding, promising to unlock mysteries we can't yet imagine. It makes you wonder what incredible discoveries are still waiting for us on the horizon. Think about a world where cosmic ideas are not confined to academic settings, but are vividly brought to life in movies, music, and literature. With his famously untamed hair and thoughtful expression, Albert Einstein became more than a remarkable physicist. He transformed into a timeless cultural figure. The question, of course, is how he achieved such an iconic status. His theory of relativity fundamentally altered our comprehension of space and time, which in turn gave artists, authors, and directors a new framework to examine abstract ideas in imaginative and relatable ways. Consequently, Einstein's likeness has been portrayed in countless cinematic forms, ranging from animated caricatures to central figures in historical narratives. His very name stirs a mixture of reverence and intrigue. But what is the source of his image's enduring power? It might be his unique capacity to bridge the gap between the immense complexity of his science and the simple, innate curiosity that defines our humanity. Ultimately, we all share a desire to find our place in the universe, and Einstein provided us with the intellectual tools for that search. Have you ever considered what people mean when they claim Einstein kick-started modern science? His celebrated equation, E equals mc squared, represents far more than a simple mathematical statement. It stands as a powerful symbol of the intrinsic connection between energy and matter. This idea was so revolutionary that it has shaped how we think about energy in our daily lives, from the power in our homes to the forces inside a nuclear reactor. Popular culture has adopted his concepts in some truly surprising ways. The animated series The Simpsons, for instance, frequently delves into scientific principles, and one episode offers a comedic take on relativity, making complex science more approachable and proving that Einstein's legacy is very much alive in the public mind. This just goes to show that science can indeed be entertaining. Now, let's consider the world of music. Musicians such as David Bowie wove references to relativity into their lyrics, merging scientific thought with artistic expression in a manner that strikes a deep chord with listeners. His song Space Oddity, for example, explores themes of cosmic discovery and solitude, subjects that were also central to Einstein's own intellectual pursuits. This beautiful intertwining of science and music stems from a shared search for meaning that resonates across all generations. However, Einstein's relationship with popular culture was not always straightforward, as his theories were frequently misunderstood or drastically oversimplified. This situation brings up a compelling dilemma. Is it more valuable to distill a complex idea for mass consumption, or should its full intricacy be preserved, even if it means some people are left behind? Einstein himself championed scientific clarity, but was keenly aware that true depth is often lost in superficial explanations. Einstein's effect on education is also quite significant. His image is frequently used to kindle the passion of future scientists. In many classrooms, he is portrayed not merely as a genius, but as a human being who contended with his own doubts and obstacles. This humanization of his story makes the field of science feel more attainable for everyone, teaching us that perseverance and curiosity are just as crucial as raw intelligence. The physicist's immense popularity also gave rise to a peculiar trend: the commercial use of his name and face. From T-shirts to coffee cups, his likeness has become a shorthand for intellect and innovation. Does this practice honor his legacy, or is it merely an effort to profit from his fame? The answer probably reflects the complex nature of our culture, where the worlds of science and commerce frequently overlap. In the realm of literature, his life and work have been examined in numerous biographies and novels that aim not just to explain his science, but to grasp the character of the man behind the legend. What compels an author to investigate his life so thoroughly? It is likely the desire to understand how a single individual could so profoundly alter the direction of human history. His influence even reaches into the domain of philosophy. Many contemporary thinkers have debated the consequences of his theories for our basic understanding of reality, particularly how relativity reshapes our perceptions of time and space. These dialogues have enriched both disciplines, fostering a continuous conversation that challenges our most fundamental assumptions. Einstein's image became so potent that it even fueled social movements. His advocacy for peace and human rights echoed through the decades, establishing him as an icon not only of scientific progress, but also of social justice. A scientist becoming a beacon for social change is possible through a steadfast conviction that knowledge must be applied for the betterment of all humankind. Of course, his legacy is not without its detractors. Throughout the years, his theories and personal life have been the subject of criticism and intense debate. Some have raised questions about specific elements of his work, which in turn prompts us to reflect on the very nature of scientific inquiry. Is science a domain of absolute certainties, or is it a perpetually evolving series of questions? Within the landscape of social media, Einstein's persona has found renewed vitality. Memes, quotations, and short videos detailing his life and theories are shared every day, affirming his lasting relevance. In our digital era, this might signify that despite all our technological progress, the profound questions about the cosmos and our own existence remain as universal as ever. Albert Einstein continues to fascinate us, not only due to his incredible scientific accomplishments, but also because of the controversies and critiques that shadowed him his entire life. What was it that so deeply unsettled some of his contemporaries? Why did his groundbreaking theories ignite such fierce debate within the scientific establishment? Let's explore the compelling world of criticism and contradiction that is tied to this brilliant mind, as even his most celebrated successes did not make him immune to dissent. During Einstein's era, the majority of scientists were certain that the universe was in a static and eternal state. In an effort to reconcile his theories with this dominant viewpoint, Einstein introduced what became known as his cosmological constant. However, upon the discovery that the universe is, in fact, expanding, he famously denounced this constant as his greatest blunder. But what made this reversal so momentous? The cosmological constant grew to represent Einstein's reluctance to embrace new scientific paradigms. Some of his peers even charged him with stubbornly clinging to outdated beliefs, suggesting he was unwilling to accept this fundamental shift in understanding. You have to wonder, did a fear of the unknown drive him to defend a cosmic model that was quickly becoming obsolete? This same resistance was evident in his stance on quantum mechanics, which was one of the most transformative theories of his day. Einstein articulated his skepticism with the now legendary phrase, God does not play dice. This statement powerfully highlights his conviction in a universe governed by order and predictability, standing in stark contrast to the inherently probabilistic world of quantum physics. This led to intense, famous debates with many of his contemporaries, such as Niels Bohr, who championed the new theory.
So why did this new interpretation of reality make Einstein so profoundly uncomfortable?
The friction between him and his colleagues wasn't just confined to quantum mechanics. His refusal to accept some of the direct implications of his own general relativity theory, like the existence of black holes, also ignited considerable debate. Even though his own equations predicted these cosmic structures, Einstein hesitated to acknowledge them as real, a situation that led this iconic physicist to question his own creation. Some critics claimed his classical training in physics was what held him back. Did his extraordinary intellect also leave him susceptible to a kind of paralysis when faced with radical new analysis? This duality in his thinking contributes to the complexity of his legacy. On one hand, you have him celebrated as the father of relativity, while on the other, he's criticized for not fully welcoming change. In the 1930s, his opposition to quantum mechanics was so strong that some even branded him a scientific reactionary. Then again, you could also view his resistance as a stand for scientific exactitude. Did his fight against these emerging theories cast him as a hero or a villain in the annals of science? You can find compelling arguments for both sides. Beyond his professional life, Einstein's personal affairs were also scrutinized and were filled with their own contradictions, as his romantic life and family choices drew criticism from his contemporaries.
The conflict between his professional ambitions and his private life fueled discussions about his priorities. It begs the question, is it possible for someone to be a genius while also being a good father or a committed partner? This query has resonated through the decades, painting a more human picture of Einstein. The perception of him was also deeply colored by the historical period he inhabited, as the turmoil of the First and Second World Wars led his ideas to be constantly interpreted and reframed to suit the anxieties of the time. His pacifist beliefs were frequently at odds with the stark reality of a world engulfed in conflict. How did Einstein manage the immense pressure from his peers to align himself with the prevailing ideologies? With the passage of time, some of the criticisms leveled against him have been re-examined, especially in light of new physical discoveries. For instance, the cosmological constant he once dismissed has made a comeback as a potential explanation for dark energy. Could it be that time has vindicated him on points he couldn't bring himself to accept during his own life? The controversies that swirled around Einstein are a reflection not just of his personality, but of the constantly evolving nature of science itself. What does it really take to be on the cutting edge of knowledge? It often means you must challenge the existing order and be prepared to endure criticism. In that respect, Einstein was a genuine trailblazer, yet he was also a man of his time, caught between the impulse to push forward and the need for his work to be understood. Ultimately, Albert Einstein's life is rich with nuance and contradiction. The critiques of his theories and his pushback against certain changes don't detract from his genius. Instead, they add layers to it. They serve as a reminder that science is a journey fraught with uncertainty, where even the most brilliant minds are confronted with doubts and challenges. What will his legacy look like in the future? While only time will reveal the full picture, his story continues to be a powerful testament to our collective human struggle to comprehend the universe. What kind of legacy is left by a man who fundamentally challenged the laws of physics as we understood them? With his brilliant intellect and unquenchable curiosity, Albert Einstein made an indelible impact on science and, by extension, on the world you and I inhabit. But how exactly has his work shaped modern physics and our perception of the cosmos? The answer isn't straightforward,
but you can see its traces in every corner of contemporary science. Einstein's creative genius provided the very foundation upon which a great deal of modern physics has been constructed. His theory of relativity didn't just upend our understanding of space and time. It also set the stage for modern cosmology. But I often find myself asking why his legacy is considered so crucial. The answer becomes clear when you see how his ideas have permeated fields well beyond pure physics, influencing aspects of our day-to-day lives. Just think about the technologies that have been developed because of his theories. From the precise synchronization of GPS systems to our fundamental grasp of nuclear energy, Einstein's influence is woven into the fabric of our modern existence. Can you even conceive of what our world might be like without these breakthroughs? Relativity is much more than an abstract idea. It has tangible applications that have transformed how you interact with the world. Moreover, Einstein's work opened the door to entirely new questions. What mysteries lie beyond the scope of our current discoveries? His theories not only solved existing problems, but also generated fresh challenges for future generations. Quantum physics, which emerged partly from questions he helped frame, has spurred advancements in computing and technology, paving the way for a future brimming with possibilities. The real question now is, are we truly prepared to face the consequences of these new discoveries? Albert Einstein's impact on our culture reaches far outside the confines of scientific labs and academic halls. You probably recognize his iconic image, the wild hair and thoughtful eyes, which has come to define our very notion of a genius. This prompts a compelling question. What does it truly take to be considered a genius in our modern world? His story and his revolutionary concepts have ignited the minds of countless scientists, creators, and philosophers, serving as a powerful reminder that our collective advancement is built on the bedrock of creativity and curiosity. Even with his immense stature, Einstein was certainly not immune to dispute. Throughout his career, he encountered significant pushback and skepticism, even from his own peers. Certain aspects of his work were heavily scrutinized, and his steadfast refusal to fully embrace quantum mechanics cemented his status as a complex and intriguing personality within scientific history. This makes you wonder if the most groundbreaking thinkers are inherently the most challenging ones, as Einstein's life seems to affirm this idea, making it an integral piece of his legacy. The conversations sparked by his work are not confined solely to the realm of physics. Philosophical thought has also been profoundly shaped by his contributions. When you contemplate the nature of space and time, you are inevitably confronted with profound inquiries into our own existence, the fabric of reality, and our specific position within the universe. Einstein's ideas compel you to grapple with these immense questions, urging you to peer past the surface of ordinary perception and ask what it genuinely means to reside within a constantly expanding cosmos. You can also see his enduring influence clearly in the field of education. The narrative of Einstein's life, complete with its hardships, victories, and his unyielding quest for understanding, remains a source of motivation for both students and teachers. His story serves as a vital lesson that science is much more than a collection of equations and data. It is fundamentally about the human adventure of exploration and discovery. From his methods of learning, you can draw the lesson that traits like imagination, curiosity, and sheer persistence are every bit as crucial as raw intelligence. His impact goes beyond reshaping physics. It alters the very way you might view life itself. His well-known declaration that imagination is more important than knowledge serves as a timeless reminder that creativity is a formidable force for progress. It makes you think about how many revolutionary concepts first arose from a simple flash of imaginative thought. Einstein demonstrates that while information is certainly essential, It merely represents the launching pad for true innovation.
Over time, his persona has transformed into an emblem for the unending search for knowledge. Today, as you and I confront worldwide crises like our shifting climate and dwindling energy resources, the scientific foundations he laid offer a framework for tackling these very problems. It raises the question of whether solutions drawn from his way of thinking are within our grasp. The key to answering that might be found in our ability to adapt his enduring legacy to the unique challenges of our time. When you reflect upon the life and work of Albert Einstein, it becomes obvious that his influence is incredibly diverse. He didn't just revolutionize physics, he left an indelible mark on our culture, philosophy, and educational systems. His legacy serves as a perpetual challenge for you to keep investigating, to keep asking questions, and to never cease your personal quest for knowledge. Ultimately, this pursuit of a more profound comprehension of ourselves and the cosmos we call home is a journey that connects us all. The universe presents itself as a boundless sea of enigmas, and when you look up at the night sky, a thrilling question naturally emerges. What is the true meaning of our existence in a place so vast and intricate? As you seek to comprehend your role in this cosmic drama, you stumble upon the same deep thoughts that have fascinated philosophers for ages. Albert Einstein's groundbreaking perspective on spacetime provides a legacy that is about more than just mathematics. It's an open invitation for you to contemplate your unique place in the universe and ask if we are simply the result of a random cosmic event. It is easy to feel like an isolated speck, adrift in an endless ocean. Yet you might wonder if each person possesses a greater purpose within the universe's grand design. Through the lens of Einstein's theories, science presents a view that disputes your everyday perception of reality, encouraging you to see yourself not as a passive observer, but as a vital component of a deeply interconnected system. This realization that time is not a fixed progression but a profoundly personal experience should make you reconsider how you live. If time itself is flexible, it underscores the importance of valuing every single moment as precious and distinct. As you delve into the nature of your own existence, you discover a universe brimming with complexity and wonder. The captivating beauty of a distant star prompts you to ask what lies behind it, reminding you that even though you are minuscule in the cosmic scale, your life is interwoven with the history of everything. That starlight has journeyed for millennia to meet your gaze, a testament to how you are, in a very real sense, a part of its ancient story. Contemplating the sheer scale of the universe inevitably leads to the question of solitude. Are you truly alone in this boundless expanse? The quest for extraterrestrial life has long been a central topic in both science and philosophy. While Einstein may not have tackled this question head-on, his work consistently inspires you to view the heavens with an inquisitive spirit. His legacy is ultimately a call to action, an invitation for you to investigate the unknown, question what is accepted, and persistently search for answers in a cosmos that is full of mysteries. Considering the existence of other intelligent beings throughout the cosmos invites you to ponder the very essence of life and the threads that connect us to everything. In our quest for understanding, science and philosophy become intertwined, compelling us to ask what reality truly is. Albert Einstein demonstrated that our perceptions might only capture a fraction of a more profound truth, showing how your personal experiences and viewpoints can shape the way you interpret the world around you. This journey of discovery naturally leads you to the powerful question of your own existence and what it signifies to be an individual within such a staggering universe. physics offers a humbling reminder that you are composed of atoms forged in the hearts of stars, meaning each of us carries the history of the cosmos within our very being. Reflecting on this fact allows you to truly value your uniqueness, while also recognizing your deep-seated connection to everything. As you delve deeper into the universe's nature, you also confront the fundamental concepts of time and space, and how these dimensions influence your daily life. Einstein taught us to see time not as an adversary in a fast-paced world, but as a cosmic dance in which we are all participants. Every moment of happiness, grief, love, and loss is a step in this grand choreography that ultimately binds us together as one. This profound interconnectedness of all things makes you wonder how your choices reverberate throughout the world. Every single action, regardless of its scale, has the potential to leave an imprint on reality. The way you treat others, care for the planet, and pursue knowledge all echo within the vast tapestry of the cosmos, shaping the legacy you will eventually leave behind in the universe. Exploring the meaning of your existence also brings you face to face with questions about death and what happens after you depart from this world. While science doesn't yet hold all the answers, curiosity about what lies beyond can inspire you to live with greater purpose. This perspective frames death not as a final stop, but as a transition, a step into the unknown that may be an opportunity to merge with something far greater than yourself. The universe, with its endless wonders and mysteries, also serves as a powerful lesson in humility. Gazing up at a star-filled sky, it's natural to feel small. Yet you are also a spark of the universe's expanding consciousness. Embracing this humility in the face of such vastness can inspire you to act with greater compassion and empathy toward everyone you encounter. Einstein's life challenges you to see that curiosity is the very engine that propels scientific progress and human understanding. He taught that questioning the known is essential, as the pursuit of knowledge is a never-ending journey, where each new question moves you closer to the truth. Sometimes the most profound answers are hidden within the simplest inquiries. Ultimately, as you reflect on the universe and your place within it, the question of your legacy comes into focus. What truly defines your existence are the bonds you form, the love you share, and your relentless pursuit of understanding. In this cosmic dance, you have a distinct role to play, and every life is a brilliant flash in the immensity of time and space, forever contributing to the unfolding story of the cosmos. The very concept of the multiverse, for example, compels you to consider the existence of other universes coexisting with our own. If this were indeed the case, you must then ask what implications it holds for your personal identity and your deepest aspirations. It raises the fundamental question of whether you are truly alone in this immense reality, or if you are, in fact, part of a much larger cosmic tapestry. Without a doubt, Albert Einstein's inheritance extends far beyond the realm of physics. His life and contributions serve as a powerful inspiration for you to continue questioning everything, to keep venturing into the unknown, and to maintain a commitment to lifelong learning. The challenge, then, is to discover how you can actively apply his inquisitive nature to your own experiences and pursuits. As curiosity is the spark that can ignite the flame of knowledge anytime and anywhere. It is also crucial for you to acknowledge that despite our significant progress in understanding the cosmos, a vast amount remains beyond our grasp. Einstein taught us to welcome this uncertainty, to find value in the mystery, and to perceive the inherent beauty in what is not yet known. In an age saturated with information, it is sometimes vital for you to step away and contemplate life's most profound questions.
So, what does it truly signify to be a human being in a universe of such staggering scale? Albert Einstein's life serves as a poignant reminder that even though your individual days might appear inconsequential in the grand cosmic scheme, each of you possesses the potential to make a genuine impact on the world. An inquisitive mind, a passionate spirit, and a deep-seated desire to understand are the essential tools that will enable you to explore not only the universe, but also the depths of your own being. In the end, this relentless journey toward knowledge is the common thread that unites every one of us. It is the core of the vast and wondrous adventure that you and I simply call life.